Hello everyone, welcome to this 13th video on Python. So in this video, we'll do a case study with a hypothetical leads and purchase data set where you will also see the usefulness of many-to-many join. So here we have two data frames that we will be loading in Python, and these are leads and purchase data frame. So leads are created when we reach out to any customers or customer shows any interest in our product, and so we have customer id, the product id, and the lead id along with the date on which the lead was created. And if that lead gets converted, I mean if the customer actually buys that product, then that information is recorded in this purchase data. So you can see that we don't have any lead ID in purchase data, and we don't have any purchase ID in lead data. So we can't exactly map which leads is leading to which product conversion. Okay. We- So here we can actually join these two data set using customer ID and product combination, but again it will lead to many join, and which will increase the number of rows. But yeah, we'll see how we'll handle that. But another thing to keep in mind is that here we are adding an additional condition that if a lead is created on a particular date, and if it does not get converted within the next 180 days, then we will say that yeah, this lead is not actually reaching that stage where the customer is buying the product. So we'll consider a lead getting converted to a purchase only if it is done within 180 days of lead creation. Okay, so let's get into the code. So here, first of all, we'll load the library, and then we'll load the leads dataset, which is the first uh, data frame. And here it's the same set of columns. We have lead ID, customer ID, product, date, year, month, and this date, which is not exactly in the right format. So we'll just convert it into this format using this line of code, pd2 date time, and then we'll use dt.strif time to actually convert it into year, month, and date format. And we'll just observe the data types of the different columns here. So lead id is integer, customer id is integer. We don't need them to be integer. We can convert them into object as well, but yeah, for now let's keep it like that. And we can see that date is also an object column. To understand if there are multiple records for a customer id in the data, we'll do a value count on customer id, and we can easily observe that yeah, there are multiple records for a customer ID. For example, here 1306 customer ID, there are three leads available in the data set. But if we do the same uh, group by and size for customer ID, product, and date combination, we can observe that it's only one. So it means that for a particular customer ID, for a particular product, there is only one lead on a particular day. So there is no duplicate lead on a same day for a same customer and product combination. Now we'll load the purchase data set. So here also we can see that same kind of columns which we have seen in the Google Sheet: purchase ID, customer ID, product, and purchase date. And we'll again convert this purchase date to proper format. So we can see it's a year, month, and date format we have now. And if we observe this combination, customer ID, product, and purchase date combination using group by and size, we can see that again there is no duplicate purchase by a customer ID for the same product on the same day. But if we do a value count on customer ID, we can see that yeah, there are a few customers with multiple purchases in this data set. Okay, so if you go to the last a few rows, then we can see that 4631 or a few few of these customers, they have only one purchase. But in the first few rows, we can see that there are many customers with multiple purchases as well. So in fact, there are 66 total customer IDs, and overall purchases were actually 87. So the first question here is how we can actually assign leads to those purchases available in the purchase table. So which lead actually led to that purchase, how we can do that. But yeah, before getting into that, let's see the shape of the data frame. So leads 181 records and purchase 87 records. And yes, it's already mentioned here that the logic that we will be applying is that we'll look at the dates between the lead creation date and the purchase date, and we will consider a particular lead leading to a purchase, which is where the days difference is the closest, and it should be within 180 days as well. So to achieve that, we'll do the next few steps. But yeah, just to track what is going on in the data sets, let's take an example of customer ID 72. So in the leads data set, if you see, for this customer ID 72, we have three records. So this customer ID 72, actually there is a record for this product D, A, and A again on these three different dates. So in 2013 January, we have one lead for product D. In 2013 July, we have one lead for product A. In 2016 August, we have one lead for product A. If you look at the purchases by this customer ID, there is one purchase in 2013 September for product A, and again 2016 September for product A. So this product D lead, it's not leading to any conversion, while these two leads may, I would say, may be leading to these conversions, because we also have to see if it is falling within that 180 days bracket or not. So to join these two table, we'll use both the columns as the key, customer ID and product, because we'll only consider a lead getting converted to a particular product if particular purchase if the customer ID and product combination is same in both the data frame. So if a lead is there for product A, then it should be converted for product A only. Okay. So that's why we are doing this join on customer ID and product combination. And as you can see from the shape here, it is 194 rows, 7 columns. It means that the number of rows increases from what is available in the leads data set because of this many to many join. So we have 194 rows, 7 columns, and if we take a look at the rows where the purchase date is present, we can see that there are 109 such rows. Okay. Now, again for the same customer ID 72, we'll see how the records are appearing in this join data frame. So in this merge data frame, leads purchase to. So we can see that there are 5 records, because for this product D, customer ID 72, product D, a lead was there, but there is no purchase. We don't find any purchase for this combination 72 and D. Okay, but for 72A combination, there are two additional leads present in the leads data set, and we do have two purchases as well. So this many to many join is leading to 4 records, 2 records present in leads data set, 2 records present in purchase data set. So this many to many join is creating 4 records for those two and two cases, and 4 plus 1 where there is no purchase. So we have total 5 records here. Okay, so many to many join is actually the overall record would be just the multiplication of number of records in those individual tables. So that is what is happening here, but we have to map the purchase to the lead based on number of days, so the minimum number of days. So for that, we'll calculate that particular column, which is days to purchase, and here we'll subtract purchase date with this date, which is actually the lead creation date, and get extract the number of days here. So you can see that now we have this days column available, and wherever it is present, actually it is showing that value. So it's not available everywhere, but yeah, wherever it is present, for example, here it is 97, 81, like that. Now we'll just short the data on this customer ID, product, date, days to purchase, all in ascending order. And because we want to pick the minimum days difference, okay, those records you want to pick, so we will just sort it. And you see now it looks like this. So 72A are coming first, and then 72D, because it's customer ID and then product. So all this 72 and product A are first, and 72D is below. So let's filter it for again this customer ID 72. And what we can observe here is that if you look closely, that for this 72A and this date 2013 July combination, okay, which lead ID is same 1148, we have two purchase IDs 2076 and 2087, and the days to purchase are 58 and 1149. So you can understand that when we are actually attributing this purchase, we'll attribute this purchase ID 2076 to this lead ID 1148. Okay, so because this days difference 58 is the minimum, and within 180 days, while this is very high and it's beyond 180 days as well. Again, if we take a look at this lead ID 1179, we are getting these two purchase IDs, but this one is negative, so will not consider this, because uh, purchase happening before a lead ID lead creation does not make any sense. And here, because it is again within that bracket of 0 to 180 days, we'll consider this. So this purchase ID 2087 will be mapped to 1179, and 2076 will be mapped to 1148, while there is no mapping for this lead ID 104. And to filter the records so that the days difference between the purchase and the lead remains within 0 to 180 days, we'll use this line of code where we are just filtering these days to purchase for greater than equal to 0 and less than equal to 180. And to pick the recent one for all these combinations, so lead ID, or we can actually group by lead ID and pick one as well. But yeah, this way also we can do. On the combination of customer ID, product, and date, we are taking head one. So you can see 1148 is actually getting attributed to 2076, and 1179 is getting attributed to 2087. And if you do size on this combination, which is actually lead ID combination, we are getting only one record. So there are 87 bookings, or sorry, purchases, which is there, for which we are able to attribute the right lead ID. And this 87 we have observed earlier as well, that when we are looking at the size shape of these two data frames, so purchase shape was 87 and lead shape was 181. So all those purchases we are able to map with the right lead ID at the end of this step, which is stored in this data frame leads purchase one. Now so it solves the first part where we want to map which lead led to that particular purchase. Now the second part is actually understanding conversion. So conversion percentage is actually the number of purchase divided by total number of leads. We can easily say that. Otherwise, yeah, that is how we can say. So in those purchases, we will not directly divide it, because we want to map it first and then we will do the division. So its conversion percentage is like number of leads who actually made a purchase divided by total number of leads. So now we have a set of map leads which is 87, but there are other leads as well for which we are not able to map the right purchase. To extract those leads, we'll again use the concept of anti join, which we have discussed in the last video, So we'll merge these two data set, leads purchase one on lead ID, and we'll keep this column indicator equal to true. So with that, we'll get this information. So left only cases are 94, both 87, and right only are 0. And here we are keeping how equal to left. So we'll pick the left only cases, and those would be the leads where there is no mapping in the purchase data set. So these are the leads only cases where you are filtering this underscore merge column on left only. So we have 94 such records here. Okay. And now just to get the overall leads data again, where in case if there is any purchase, we'll have those records. Otherwise, we will also have those leads where those are not finally getting converted into a purchase. So to do that, we'll just concat these two data frames where we have leads only data frame where we have leads where there is no purchase, and this leads purchase one is actually the attributed data frame. So when we concat these two, we are again getting 181 records, and we'll just create a column here which is converted, and we'll just add a flag converted to be 1 when this purchase id is available, otherwise it would be 0. And you can see in this map concatenated data frame, because it's first leads only and then leads purchase 1, in the last set of records you will have all the cases where the purchase date is available, and the first set of records you will have cases where this is null. So first 94 records we don't have any purchase date, and the rest of the records we have those purchase information. So once this converted column is created, we can, if you do value count, we can see that only 87 leads are actually getting converted into products where there is a purchase made. And if we just normalize it, we can see that yeah, the conversion percentage here is 48%. And we can get the same conversion percentage by product as well with this few lines of code. And here what we are doing is that this all leads data set, we are just grouping it on product. So to get the count of leads, we'll use lead id and count. To get the converted cases, we'll just do sum on converted cases. And to get the conversion percentage, we'll do mean on converted flag column. And from here we can observe that not all the products are getting converted in the equally actually. And this product A, it's 53% conversion, product B 50% conversion, product C has the least conversion of 33%, and product D has 54%, which is highest, and product E has 52% conversion. So I hope you will find this video to be useful, and you may encounter a project where you need to apply this logic to get the right results. So do subscribe my channel, like the video, and share it amongst your friends if you really find it useful. Thank you, and see you in the next video. Thanks.